This year we are studying the history of humans. But how far back does that history go? Well, written history only goes back about 5,000 years. 3,000 years if we really want to understand what we're looking at. But humans have been around for 300,000 years. We have questions. We want to know more about these humans. Where did humans start out on planet Earth? We know that modern humans arose in Africa between 250 and 300,000 years ago. We know this because we find fossils of them in Africa around this time period. The fossils of the earliest Homo sapiens are found across Africa, and these early humans were not alone. The debate continues of exactly how many different species of humans there were. Some estimates put the number as high as 20 or 22. Imagine 22 different types of humans living, but the only one left is Homo sapiens. All of the other species have gone extinct. I'm going to tell you the story of human evolution and migration as the best science has put together up to now. There are still lots of mysteries, and every year we find new pieces that either add to the mystery or fill in some of the gaps with new knowledge. Let's start with a discussion of how organisms are related to each other. For the most part, we define a species as organisms that have similar characteristics that are capable of breeding with each other. For example, dogs are all the same species. You could have big dogs and little dogs. You've got poodles and chihuahuas and golden retrievers. But if you take a golden retriever and a poodle and you cross them, you can have a golden doodle. A golden doodle is just another type of dog. It's still the same species. Our species is Homo sapiens. We have certain characteristics that define us. Some species we are more closely related to, and some not so closely related to. We categorize organisms based on how similar they are to each other. We look at their physical characteristics and their DNA. And from this, we can build a family tree of all the organisms and how they're related. There are categories and subcategories. We have kingdom, phylum, class, order, family, genus, and species. Humans and other great apes are in the family Hominidae. Lesser apes are the gibbons. Other primates, like lemurs and monkeys, are in the same order but distantly related. So if we build a family tree of all of these relationships between humans and our ancestors, we start to see how we're related and who we're most related to. Hominins are the part of the family tree that are not gorillas, bonobos, or chimpanzees. After several million years of separation, we have distinct species emerging and then going extinct. Homo sapiens are the only species of humans that is still around. All of our ancestors are dead. Looking at fossils is how we're able to tell the story about what happened to them, where they were, and who they were. Right now we're digging into the earliest reaches of human history. There are no written records where we're going. We have to use other types of clues. We have to use the fossil record. A fossil is remains of an organism that is preserved in the rock. This is a fossil of a clam. From Northern California, you can see the layers of where the clam shell had its hinge, a lot like this modern clam. This is a mussel, some modern shells, and you can see how they have the same type of hinge that this fossilized clam has. In order for this to become a fossil, the shell needed to be buried underneath the ground. In order to turn into a fossil, it needs to have sedimentary rock, it needs to be covered up, and over time, more and more soil and sediment covers it up, and as it sits there, the parts of the shell that were made out of calcium carbonate are slowly replaced with minerals, and those minerals turn it from a shell into a stone. That is how a fossil forms. So maybe your next question is, how do we know how old a fossil is? How are fossils aged? There's two ways that we age fossils: relative dating and absolute dating. Relative dating looks at the layers of sedimentary rock. The oldest fossils are going to be down lower in the soil, and the newer fossils are going to be higher in the soil. That is relative dating on fossils. Depending on how deep they are, less deep, they're going to be younger. It doesn't give us an actual age, it just gives us a relationship to know what came first and what came later. Absolute dating gives an age in years. This is how it works. Things like wood, bone, and igneous rocks can be dated by radiometric dating. It uses the half-life of unstable elements to determine the age. All matter is made of atoms. Some atoms are unstable and they'll break down to form a different type of atom over time. We've studied, so we know about how much of each element should be present in a recently created piece of wood, bone, or igneous rock. We know how long it takes for those unstable atoms to break down and turn into the new elements that they would be. To determine the age, we count to see how much is left. First, let's talk a little bit about atoms and instability. All matter is made of atoms. Atoms are made out of protons, neutrons, and electrons. Depending on how many protons they have, there would be different elements. Each element has a different number of protons. And these atoms like balance. They like to have the same number of protons, neutrons, and electrons all packed together. Occasionally you have atoms with a few more neutrons than protons. These atoms are unstable. If it's unstable, it's going to break down over time. One of those neutrons is going to turn into a proton, and it will change what type of element it is. Now let's talk about time. Unstable elements break down over time. We measure this time in half-lives. A half-life is how long it takes for half of that unstable element to break down. This is something we know because we have measured it. It is a very slow process, but we can measure them. We know the rate of change for these unstable elements. Some of the most common ones are carbon-14, which breaks down over 5,000 years of a half-life. The half-life of potassium-40 is 1.25 billion years. For really old things, we use uranium-238, which has a half-life a little bit more than 4.5 billion years. Carbon-14 has a half-life of 5,000 years. So if this bone represents the total amount of carbon-14 that's in the actual bone, then we're going to say that this is going to break down. Half of the carbon-14 will break down after 5,000 years. After another 5,000 years, another half of it breaks down. After another 5,000 years, and after another 5,000 years. So at the end of the time span, maybe I only have this much carbon-14 left in the sample. So as I start my measurement in the present day and I take this piece of bone and I measure it and I find that it only has this much carbon-14 left in it, doubling as I go. So if this is how much there is now, if I double that, I know that it's at least 5,000 years old. If I double that, I know it's at least 10,000 years old. If I double that, I have at least 20,000 years old. If we double that, we know it's at least 40,000 years old. This is the way we work our way backwards using carbon-14 dating to know how much there should have been in the first place and identifying how old our specimen is. Who were these people that were our ancestors? Where did they come from and where did they go? They were migrating. To migrate means to move to a new place. The migration out of Africa started about 200,000 years ago. Why did they move? People move for lots of different reasons, but this process took hundreds of thousands of years. Maybe they were looking for better climate, better resources, better access to food, or maybe the weather was just a little bit nicer than the place where their grandparents lived. Humanity began in Africa. This is the continent. Around 100,000 years ago, humans started to migrate out of Africa. 200,000 years ago, they started migrating from Eastern Africa to Northern Africa, to Southern Africa. 100,000 years ago, they started leaving Africa, traveling into Asia. 50,000 years ago, they started migrating from Africa and Asia back up into Europe. 30 to 35,000 years ago, we see some of these humans migrating across Asia down into Australia. How did people cross over to Australia? You see Australia down here, quite a ways away from Asia. How did they get there? How did people get from Asia all the way across to North America? How did that happen? This is where we talk about climate. Climate is a long-term pattern of weather. Weather is something that happens from day to day, from month to month, but climate is something that is a pattern that goes over many years or hundreds of years. Climate can drive people to migrate. If the weather gets too cold, if they can't access the resources that they need, the food that they need, they're going to move. If it gets too warm and they're not able to grow crops or find the food that they're looking for, maybe they move to a cooler climate. When the Earth's global average temperature drops low, we call that an ice age. That's when the water that's supposed to evaporate and rain down and evaporate and rain down and sometimes comes down as snow, suddenly when it comes down as snow, it's not melting again and it stays frozen. And so up in the mountains, you have the buildup of glaciers, ice that stays up there for season after season after season. And if that ice is not melting, then it's not going back into the ocean. And that means that the level of the ocean water drops. When the level of the ocean water drops, you see new pieces of land that were always there before, but they were under the water. Now those pieces of land are available to anyone who wants to migrate. They can just walk across. 30,000 years ago was one of our glacial maximums. The water level dropped low enough that the area between Asia and Australia was just one large stretch of land. 10,000 years ago, the same thing happened up here in North America. We call that the Bering Strait Land Bridge, a stretch of land that allowed people to walk across from Asia into North America. 12,000 to 15,000 years ago, people started walking across that land bridge. They started traveling, and the evidence shows us that this happened several times. It wasn't just one crossing of one group of people. It was over multiple crossings, multiple groups of people coming over. By 9,000 BC, every continent on Earth, with the exception of Antarctica, had humans living on it. This is the basic story of our most accepted theory of evolution and migration. There are still lots of questions. In fact, just last week we had a new article published on a discovery in White Sands, New Mexico. They found fossilized footprints of humans that were walking on a muddy beach 30,000 years ago. And this isn't the only older fossil site in the Americas. There are ones that are across the world that give us questions, make us think, and make us wonder, what more can we learn about the history of humans?